Hey everybody, welcome back to another exciting math video. We are in Algebra 2. We are in Lesson 1 still. We're just finishing up Lesson 1 today. We are going to look at Table C on page 4 if you're looking in your book. And it is on properties of exponents. Properties of exponents. Now, like I said, this is a fast-paced book. It's just jumping from topic to topic. Basically, in lesson number 1, there's like 4 different topics that the book is talking about. So, in this lesson, we'll talk about exponents, and then we'll talk about basically translating algebra as well. Table C talks about the product rules, and there's one product rule, there's 2 power rules, there's 1 quotient rule, and then 1 zero exponent rule. So let's talk about those, what they mean, and what they look like. So the first one is the product rule. The product rule. Well, when you hear the word product, you should be thinking multiplication, because the word product is the answer of a multiplication problem. So if you have, for example, 2 cubed times 2 to the 5th. Sorry about that. I need to figure that out and fix that. You know what I'm saying? It messes with me all the time. So if I have 2 to the 3rd times 2 to the 5th, and I want to find the answer to that problem, I need to apply what's called the product rule. Why the product rule? Because we are multiplying. We have a product. These are 2 factors, okay? And so we are looking for the answer, which is the product. So we need to use what's called the product rule, okay? In the product rule, what you would do is you would take this, not times this, because you're thinking product, so I must be multiplying. So 3 times 5 is 15. No. What you would do there is you would take that plus that. You add the exponents. Okay? So you would get 2. 3 plus 5 is 8. 2 to the 8th is the correct answer. Now let's talk about why that is. Why does that happen? Because not only is it important to know that it happens, it's important to know why it happens. And you'll, as you go through my class, you'll be hearing me say, you know, kind of like the whys. Always ask yourself why. Why is that? You know, question. Ask yourself questions. Why did that do that? Why does that look like that? And sometimes you can figure out your own question. And then sometimes, you know, it helps to ask questions where you're asking the teacher, asking other classmates, things like that, of why. So let's look at the why. Well, what does this mean? Here's what this means. 2 times 2 times 2. That's what that means. 2 to the 3rd. And then if we take times, what does this mean? Well, that means 2 times 2 times 2 times 2 times 2. So we have 3, that's the first one, and then we have 5, that's the second one. Okay? And so now look what we have. We have 2, that's our base. 1, 2, 3, 4, 5, 6, 7, 8 times. That is what's called the product rule. Okay? The product rule. When you have exponents and you are multiplying exponents, you add the exponents. Very, very important for you to remember that as we're going through Algebra 2 class. All right, the next one is the power rule. The power rule, and this is power rule 1, we'll call it. Well, if you have a power to a power, or in other words, you have something like this, well, let's actually use, well, you will use A, that's fine. A to the 3rd, and then we're going to put that to a power. So we'll put this to the 6th power. A to the 3rd to the 6th power. Okay? Well, in this, what we realize is that we add, but now here's we got to look at this, and here's something that's going on. It's a little bit different. We're not multiplying powers, we're doing a power to a power. So what does this mean? Well, here's what this means. A cubed times a cubed 6 times. I think that's 6 times. All right, that's what that means, because that is to the 6th. A cubed to the 6th. So now if you look at this, what would the answer be? Well, now we could go back to the power rule, or the product rule, and we could say, okay, let's add these up. So 3, 6, 9, 12, 15, 18. This is a to the 18th. That's what that equals. You say there's got to be a faster way of doing that. There is. Check this out. This is super fast. You just take 3 times 6. Bingo. There's your 18. 3 times 6 is 18. So the power rule, when you're taking a power to a power, you multiply. When you have the product rule, when you're taking a power times a power, you add. Power to a power, you multiply. All right, and so then we would have the power rule 2. So power rule 2. And this one is if you have something like AB to the 4th. AB to the 4th. So I've got 2 things inside of here, but they're both to the 4th power. And here's what it is. The easiest way for me to tell you how to do this is that you are going to distribute. Okay? The easiest way for me to tell you that is to distribute. So in other words, you're going to take this 4 and you're going to distribute it to both of those. So what's the answer here? The answer is, A to the 4th, B to the 4th. I don't know what's going on here, but this thing is being crazy. There we go. All right, A to the 4th, B to the 4th. That's going to be your answer there. So if you have anything like if you have 2 things inside to a power, you just distribute the power to both of those, and that would be your answer there. All right. Next is the quotient rule. The quotient rule. Just like when I said the product rule, when I say the quotient rule, something should come to your mind. You should be like, I've heard that before. Where have you heard the word quotient before? That's right. A quotient is the answer to a division problem. Okay? So remember, if I had like 3 into 30, my quotient would be 10. My answer is my quotient. Okay? So this is going to have something to do with division. Okay? So here's what this one looks like. If I have like 2 to the 6th power divided by 2 to the 4th power, what I'm going to do is I am going to, remember what we did with the, let's skip back up here and look at the product rule. Remember what we did with the product rule. We added right there, right? Okay, to get 8. Well, with the quotient rule, what we're going to do is we're just going to take this and we're just going to subtract. In other words, 6 minus 4. Let me put the minus sign on that. 6 minus 4, and 6 minus 4 is 2. So we're going to get 2 squared. Technically, that's 2 squared over 1, but we don't have to write that because what ends up happening here is this is going to cancel out to give us a 1. But we don't have to write that there because we know that anything over 1 is always itself. So that's just going to be 2 squared. Let me show you one that doesn't have it that way. So let's say that it's, let's just do it backwards. Let's do it 2 to the 4th over 2 to the 6th. Well, now we're going to do the same thing, but we're going this way, but we're still going to subtract. 6 minus 4 is 2. But look, the bigger one's on the bottom, so the 2 squared has to stay on the bottom, and we get that over a 1, because that's going to cancel. When we do our subtraction, that's going to cancel out to 0, or it's going to cancel out to a 1 in essence, because if this cancels out to a 0, what is anything to the 0 power? Anything to the 0 power is 1. That's basic algebra stuff. Okay? So you should have learned that in last year's algebra. So this kind of cancels out because we get 2 to the 0. Well, 2 to the 0 equals 1. Here we get 6 minus 4 is 2, so that gives us the 2 squared. So if the bigger number is in the bottom, which it was here, then we're going to get a fraction. If the bigger number is in the top, like it was here, we're going to get it over 1, which we don't need to write. And so we don't get a fraction. So that's something to pay attention there with the quotient rule. And then the other one, the last one, is the zero exponent rule. The zero exponent rule. And unfortunately, I just kind of ruined this one because I just taught it to you in the step before. But anything to the 0 power always equals 1. 18 to the 0 power equals 1. A million to the 0 power equals 1. Anything to the 0 power always equals 1. Okay. All right. Next thing and last thing we're going to teach in this lesson is, let's see, y'all. How to write. Let's do this. Let's write. There's an example here, and it uses using these things, but it says write these without negative exponents. So if I have x to the negative 2, let me show you what that means in essence. X to the negative 2 always equals the reciprocal, and this is on page number 5 in your book. It always equals the reciprocal. What is the reciprocal? The reciprocal is 1 over that. So basically it always equals 1 over x squared. So if you want to turn a negative exponent positive, you flip it into the top. What happens if it's already in the top? So over, we'll say this is over 5, for example. Oh, it's negative. Well, if I'm flipping it to the bottom, then I'm just going to take it down there, and I'm going to put 1 over, in this case, it would be 5x squared, is what that would look like. So in order to take a negative 1 to the bottom, you flip it. In order to take a negative 1 from the top to the bottom, you flip it. You just move it down. What happens if it's already in the bottom? Okay, so it's 1 over x to the negative 2. Well, now we're going to flip it back to the top. So in order to flip it back to the top, we're just going to move it up. So it's going to be x squared over, flip that down, 1 or just x squared. So that's what's called the reciprocal. The reciprocal, whenever you have a negative exponent, you flip it to the top by just moving. Basically, you move it to the top and you move the 1 to the bottom. In order to move it to the bottom, you would move it basically just flipping it one way or the other. That's how negative exponents work. All right, so let's write this one without a negative exponent. 3x minus 2 y to the 4th over c to the negative 3 z. All right, how are we going to write that? Now, our goal here is to write this without negative exponents. So how are we going to write this without negative exponents? Well, here's what we're going to do. We need to flip this to the bottom. Now notice, these are like separate things right here. Okay? The 3 is separate, the x minus 2 is separate, the y to the 4th is separate, the x to the negative 3 is separate, and the z is separate. Those are all separate terms. Okay? And so what we want to do is we want to take this one and flip it to the bottom. Well, the way that we do that is we would say, okay, so let's just take it piece by piece. Let's leave the 3 up there. Let's flip the x to the bottom, so it's going to be x squared. The c negative 3 has to come up to the top, and so that's going to be c cubed up top. The y4 gets to stay. Why does it get to stay? Because it's already positive. And the z gets to stay because he's already positive. So there you go. Basically, we're using the reciprocal idea, and we're just flipping things negative ones. Now, we leave the positive ones alone. So flip the negative 1 to the bottom, flip the negative 1 from the bottom, the C3, we're going to flip it to the top, okay? And that changes the signs when we do that. I'll show you in another video why that is, why flipping it to the top does something. But yeah. All right, so now the next thing that next skill, I guess you could say, that we want to be able to do is we want to be able to write one without a denominator. So this one has a denominator in it. So in other words, we want to take every piece of this denominator and flip them all up to the top. And we're going to end up with some negative exponents here, but the goal is to write with no denominator. That's what we're trying to do. So if we take this 3 and flip it up here, we're going to get 3 to the negative 1. 3 to the negative 1. Now, the U5 is already there. The V3 is already there. We're going to flip the x up, and we're going to get x to the negative 1. We're going to flip the y up. We're going to get y to the negative 2. We've now written that with no denominator. Okay? And so sometimes they want you to write it with no negative exponents. Sometimes they want you to write it with no denominator. So you can look at both of those two examples that I just did again. If you want to, rewind it and check it out if you're having trouble with that. But basically the idea is using the reciprocal to flip things up and down. And the reason we do that is to either get rid of the negative exponent or to get rid of the denominator. Depends on what the question is asking you to do. All right, one more thing and then we'll be done. Is on page number 6 in your book is what's called the Table D Common Operation and Relationship Symbol. One thing that you need to be able to do in algebra is you need to be able to translate from algebra to English. In other words, you need to know this is 3 plus 7, but they might say it different ways. So look through that. They use... For plus, they use words like increase. They use things like sum. And so you have to be ready for different words in algebra, different ways of saying plus. In subtraction, you can see some words there. They use minus, subtracted, decreased, difference. And so you need to be able to know those words as well. With multiplication, you have times, multiply, product. So be ready for those words. Division, divided by, quotient. We just talked about the word quotient. Or they could say it in fractional form like 3/7, 5/6. Well, that's a division problem when they're saying it like a fraction. In algebra, you need to know a lot about this right here, the word equals. Okay, and so sometimes they'll say equals, but a lot of times in word problems they'll say is. 5 times 3 is what? And then you put an X. Or they say 5 times what is 15? And then you would know that that was 3. Okay? So when you hear the word is, think equals. When you hear the word is, think equals. Inequality. This one is sometimes my students struggle with this one. Inequality. Less than, greater than. Okay. So the less than sign points to the left. And so this is less. The greater than sign points to the right. So this is greater. And then if you put a sign under it, that would be equal to. So that would be greater than or equal to. So if you put a little line under that, that adds equal to it as well. So for instance, if you take 5 is less than or equal to x. So that means that every x has to be 5 or less. Actually, 5 is less than x. So in that case, x would be greater than that. So make sure that you kind of look at the signs. Make sure that you know how to use those signs. Again, that was Algebra 1 topic, but If you're looking at your book there, look at page number 6, and it should be able to help you out with those different words. Okay? All right, that's all I have for you today. Hopefully you enjoyed the class. If not, hey, there's maybe tomorrow's class. All right, we'll see you later. Have a good one. Bye-bye.